Ichizero.
There are several universal laws in this world, and we are born of those laws, guided inexorably in a single direction. What is reality? We delve into our roots. Can you truly say you are here right now?
Huh? Oh, of course I'm here.
Are you certain?
What, am I not here?
Very well. Then let's have a look right away. Modern science has illuminated many things that were once beyond our understanding. Today, both the cosmos, seen through telescopes, and the tiny worlds, seen through microscopes, have had most of their mechanisms laid bare. And that knowledge is shared worldwide. As proof, our advanced way of life is sustained, isn't it? Or so we might think. In truth, we understand very little. We have discovered so-called laws. If we do this, that will happen. And we use them. Yet the reality is that, regarding the underlying mechanisms, the why and the how, our grasp is only skin deep. So why is it that we know the sun always rises in the east and sets in the west? The reason is simply that it always has. All we truly know about the sun is that it rises in the east and sets in the west. We do not actually know why it moves so. Take, for example, the heliocentric model that says Earth is a sphere. Those who first heard it must have been astonished. The idea that the very ground we stand on is a sphere is downright staggering when you think about it calmly. I remember being shocked as a child when I learned the Earth was round like a ball. It was a world utterly beyond anything my own experience could imagine. This heliocentric theory predicted that the mechanism, the reason, why the sun appears to rise in the east and set in the west, is that Earth orbits the sun and rotates on its axis. That must have been deeply shocking to people of the time. It was comparable to someone today claiming that Earth is hollow and harbors an inner world. By the way, how did our ancestors confirm that Earth is round? Verified by lunar eclipses. During a lunar eclipse, Earth's shadow cast on the moon reveals that Earth is spherical. Verified by ships and the horizon. A ship emerging over the horizon shows its mast first, then the hull, demonstrating Earth's curvature. Verified by constellations. Stars invisible in one place are visible elsewhere, indicating a round Earth. The first empirical proof is said to have come from the circumnavigation by Ferdinand Magellan and Juan Sebastián Elcano. Yet each of these reasons on its own is insufficient to state definitively that Earth is round. Even a successful circumnavigation does not guarantee beyond doubt that Earth is a sphere. After all, one might have looped around it some other way. However, by accumulating such facts, people could conclude that the likelihood of a spherical Earth was high. Today, we can actually send humans into space to confirm Earth's roundness. But it was only by matching circumnavigation with surveys and many observations that people on the ground came to believe in a spherical Earth. This style of reasoning is called deductive logic. Deduction stacks logical steps on already known rules to reach a conclusion. All people grow old.
What? I'm never getting old!
Some might insist they are forever 17, of course. Jokes aside, as human beings, we inevitably age. You could call that an inescapable fact. In this way, even without seeing most things firsthand, we can know and trust that Earth is round. Yet there is one thing we must keep firmly in mind. We are capable of questioning common sense, those very principles and rules. This is not to say we should doubt everything. Without doubt, we cannot arrive at the truth. There is a word, science. Hearing it, we picture a discipline that unravels every phenomenon and mystery, pursuing cosmic truth. Yet such images do not define science. They describe just one of its purposes. Debates also abound over whether science is correct. But we can state unequivocally that a scientific explanation is more reliable than a non-scientific one. A dictionary says science is systematic study of a field by objective methods. But what does it mean to study something systematically by objective methods? Even if a study is systematic and objective, who can prove it absolutely correct? Naturally, no one can prove it absolutely. In fact, what we deem scientifically sound is established by ruling out alternative possibilities. By dismissing many incorrect possibilities, we raise the purity of what remains true. That is the essence of science. Therefore, a scientific account is, of course, more accurate than an unscientific one. Thus, the proposition Earth is a sphere is supported, for example, by the fact that no celestial body of comparable size is non-spherical. Consequently, if a body similar in size to Earth were found that was not a sphere, the proposition would be disproved. Science proceeds through many attempts at refutation, steadily increasing the plausibility of a proposition. When we take it for granted that Earth is round, it is equally important to ask, what if Earth were not round? That is the scientific mindset. From a young age, we are actively taught what we ought to know. Yet what may truly matter is how we think about information, knowledge, and evidence. The other day, something happened. There was someone who claimed they could summon UFOs, so I said, by all means, please call one in. Then one person said, a UFO is already above us. I lifted my gaze overhead. I don't see anything. Then the person told me, those who can see, see.
You're right. Over there, right? Amazing.
Fearing I might spoil the mood, I decided to watch them from a distance. And I thought, maybe the UFO really had come. But in a setting where no scientific discussion is possible, I could say nothing. Common knowledge and a few hypotheses. Where did the world we live in come from? And where is it headed? For what reason, and by what mechanism, does it exist? Such questions are full of romance, and countless hypotheses and theories have been proposed. Notable examples include the mathematical universe hypothesis, the multiverse theory, the flat earth theory, the holographic universe theory, the cyclic universe theory, and the simulation hypothesis, among others. Each is fascinating in its own right, so if you're interested, do look them up. Some universal laws. Earlier I said that science raises the purity of truth by doubting, yet there are things in this world that are beyond doubt. What would be beyond doubt? Laws. A law is a relationship that holds under certain conditions, anytime and anywhere. Put differently, it states that a phenomenon will behave the same way for anyone whenever the conditions are identical. For example, if you strike a sound, you will hear it. Or if you throw an object, it will fall to the ground. We might not fully grasp the mechanism, but we know that if we do, X, Y reliably follows. Sun rising in the east and setting in the west is one such law. In most cases, the correctness of a law is beyond doubt. Of course, the conditions under which a law holds can be questioned, and it is impossible to prove completely its mechanism or reproducibility. In other words, whether the law will hold forever. Yet it is also true that, compared with underlying mechanisms, laws possess an overwhelming degree of reliability. To explore the workings and origins of this world, let me introduce 3 laws or principles that I consider especially important. Einstein's principle of the constancy of the speed of light. This principle states that, for all observers moving at constant velocity with respect to one another, the speed of light in a vacuum is always the same, regardless of how the source itself moves. It further maintains that space and time are not universal or absolute. Distance, and thus space, and time themselves are scales that emerge secondarily from the ultimate speed limit, the speed of light. It is startling to learn that quantities we assumed absolute, space, distance, and time, are all derived from the universe's ultimate speed. Ray Kurzweil's law of accelerating returns. This law says that in technology, whenever a new capability is created, that capability is itself used to drive the next advance, so at every stage of evolution, progress builds atop the products of the previous stage, producing exponential growth. Kurzweil notes that the same law applies to biological evolution as well. The rate of biological evolution accelerates exponentially, and in electronics, transistor density follows the exponential pattern famously captured by Moore's law, Bernoulli's law of large numbers. If you toss a coin many times, you can expect heads to appear in roughly half of the trials. Moreover, the more tosses you perform, the closer the proportion of heads comes to 1/2. In short, the law of large numbers says that the more a phenomenon is repeated, the more its outcomes converge on the theoretical probability. If you were to toss only 5 Othello discs, you might get all black, or a 50-50 mix. The results vary. But if you toss 10,000 discs, they would settle at almost exactly half and half. These 3 laws I have introduced are therefore fundamental to understanding our world. They can also help to reveal the true nature of the world that unfolds before us, the world we call reality. Next, let us consider what exactly the reality before our eyes is. So, what is reality? According to a dictionary, it is that which appears before us as fact, as opposed to fantasy or ideals, the things or states actually present right now, that which actually exists or is realized. Wikipedia says reality is what is presently manifest before us as fact. Or, reality may be that which fundamentally constrains and defines the events experienced by individual subjects from outside, or the provisional field that underlies such events. It is further written that what is distinct from reality is something formed by combining lies and truths. One gets the impression that the words fantasy and ideal came first, and that the term reality arose in contrast to them. When pondering what reality is, another issue arises: how can we guarantee that people are sharing the same reality? It is impossible to rule out the possibility that only I am seeing a different reality. Perhaps everyone else is merely an NPC, characters created solely for my benefit. Even what it means for us to share the same reality is something we are unable to determine with certainty. Virtual and real. When we hear virtual and real, they sound like opposing terms, practically antonyms. The dictionary states, in virtual reality, a simulated reality deemed lower level or derivative, relative to a higher or more fundamental reality, necessarily possesses an aspect of fiction. I see, though I can't say that clarifies much. In short, reality is the basis, and the simulated reality that springs from it, virtual reality, can thus be called an artificial imitation, not true reality. By contrast, the reality in virtual reality refers to a reality that, at least with respect to its essence or its effects, is equivalent to the actual thing, a truly substantive reality. Indeed, we already create virtual companies or virtual machines that replicate only the functional aspects of a firm, and we use them as if they were real. There is also the word reality, meaning the quality of being real. Realness, in this sense, is the term we use to say whether something has any of the properties of reality, and if it does, how strong or weak those properties are. We might want to know whether something is virtual or real, yet the term reality itself suggests that virtual and real are not an either-or pair. Rather, virtual and real describe positions along a continuum of degree. It is similar to saying something is more or less comfortable, or has higher or lower economic efficiency, instead of simply asking whether such properties exist at all. So what exactly is the relationship between virtuality and reality? There is an answer that makes intuitive sense. Reality is virtuality that remains stable over the long term, something that does not vanish like a fleeting dream or illusion, something that can be reproduced again and again. Take the sun, which rises each day. It has never once broken that schedule. It always comes up in the east. That is precisely reality. Even if one day the sun failed to rise, that event too would be reality. Put plainly, reality may simply be the world with which we are most familiar. In other words, reality is virtuality that has become extremely stable. For instance, regarding one's partner and children as an intimate family could be called a virtual reality. But if that virtual reality recurs day after day, those virtual family relationships will exist around you as an unquestioned reality, or so you would surely feel. Related to the word reality is the term fact. What is the difference between reality and fact? A fact refers to a universal event or situation that has actually occurred. By contrast, reality denotes the facts that an individual has seen, heard, or experienced through the filter of their own perception. Facts are the results obtained by quantitative measurement or by using scales common to everyone. In short, things that appear and feel the same to all observers are facts, leaving no room for interpretation. Reality, lacking a quantitative shared scale, varies greatly depending on the person, the perspective, and the era. Counter-arguments to the simulation hypothesis. In October 2017, an article was released declaring the simulation hypothesis has been completely debunked. Zohar Ringel, a theoretical physicist at Oxford University in the UK, and Dmitry Kovrizhin of the Hebrew University of Jerusalem, published a paper in the journal Advanced Science that reportedly shows our reality is not the product of a computer simulation. Does this mean that simulating the world at the quantum level is physically impossible within a finite universe? At present, the simulation hypothesis is unfalsifiable. We have no way to test it, and so it is not recognized as scientific. We have no means of scientifically proving it now, yet we can still gather circumstantial evidence that our world might be a simulation. In modern particle physics, the particles that make up atomic nuclei are regarded as dimensionless, purely mathematical points. At this stage, one must ask, what is existence to begin with? Such questions make it hard not to sense the possibility that our world is a computer simulation. That said, while we cannot scientifically prove that the universe is a simulation, we can certainly demonstrate the feasibility of creating such a simulation. In other words, we can build a convincingly real simulated world. While there is little point in debating the unfalsifiable, the earlier paper claiming our universe is not a simulation can be easily countered by introducing the idea of LOD, level of detail, a technique that adjusts detail according to the apparent size of an object in view. Born in video games, LOD gradually simplifies distant buildings, characters, and other objects to keep overall processing within reasonable bounds. Whoa, stop right there. This game you're also engrossed in certainly simplifies distant buildings and other objects because they don't need intricate detail. This is LOD, a technique now commonplace in gaming. Yet the same phenomenon occurs in reality. Our eyes capture images on the retina, whose resolution is said to be 576 million pixels. For reference, Full HD is 2 million pixels, 4K is 8 million, and 8K is 33 million. In practice, however, the retina's effective resolution for moving images is thought to be only about 7 to 8 million pixels. That means anything smaller than a single 8 megapixel pixel we are viewing need not be rendered in detail. It can simply be treated as a dot. LOD is a form of abstraction. By using it, objects that are extremely far away or too tiny to be seen can exist without being individually computed in fine detail. We perceive celestial bodies drifting in space merely as spheres, and you rarely see anyone viewing the cup before them as a collection of quanta. In short, whether dealing with quanta or the cosmos, so long as you know the governing principles, you needn't compute everything. Moreover, in the real world around us, nearby objects and distant ones alike are already abstracted. There truly are laws that make one suspect our world must be a simulation. One of them is Bernoulli's law of large numbers. As we said, this law holds that if you toss many coins, the more you toss, the more the number of heads approaches half the total. That is, the more a phenomenon is repeated, the more it converges on its calculated probability. Put simply, when many objects are gathered, the whole always settles into the same average outcome. A single tree becomes a forest when many are seen together. From an overhead, macro perspective, the reason a collection of things appears abstracted into something else lies in Bernoulli's law of large numbers. Statistics, indispensable to modern science, rests upon this very law. Therefore, the earlier objection about insufficient computational resources can be easily dismissed through abstraction, and it is technically possible, indeed almost certain, that we will create a simulated reality. If we can build a virtual reality that feels real to us, we cannot rule out the possibility that our own world is virtual. Assuming virtual reality is feasible, the next question is, what is the probability that our world is virtual? Many will know that Elon Musk and other prominent figures have spoken of the high likelihood that our universe is a virtual reality. But you may wonder what reasons lie behind that claim. Here is why. Some 13.8 billion years ago, the universe emerged in the Big Bang. Within the expanding cosmos, newborn stars cycled through life and supernova death, forging a wealth of elements. Around 4.6 billion years ago, our solar system formed. History tells us that life arose about 4 billion years ago, and by 500 million years ago, Earth teemed with diverse organisms. Humans appeared a mere 5 million years ago, and evolved complex language only 70,000 years ago. And roughly 2,000 years ago, humanity finally formed nations. The Industrial Revolution, which catapulted civilization forward, happened only 300 years ago. Since then, modernization and technological breakthroughs have continued. The information communication revolution, brought by the internet and computing, took place just 30 years ago. In recent times, supercomputers with exascale performance have appeared, and their computational power is still rising at an exponential pace. Such capabilities and technologies evolve acceleratively, following the law of accelerating returns. Indeed, throughout history, that law has never been broken. It is one of our universal principles. Therefore, for intelligent beings like us, technological innovation will unfold faster than the blink of an eye on a planetary timescale. Even we, living today, are already running countless simulations, that is, computational trial and error. The scope and complexity of those simulations are skyrocketing. It is easy to imagine that, in virtual worlds created by computers, humanity will actively simulate life itself. Whether in games or elsewhere, simulations will become ever more sophisticated, and their numbers will grow acceleratively. Suppose one person runs an average of 10 virtual reality simulations in the course of a decade. With 7 billion people alive today, that would be 70 billion simulations in 10 years. If each of those simulations is an ultra-high fidelity virtual reality, then at this point we already have 70 billion manufactured realities. And within each such reality, life would undergo exponential evolution just as it does in our own. If that cycle occurred twice, every one of those 70 billion worlds would spawn another 70 billion virtual realities. In just 2 cycles, we reach roughly 49 trillion x 100 million, or 49 quintillion virtual realities. How many more cycles might follow, no one can predict, but the total would plainly exceed any number we could ever count. So, in probabilistic terms, after just 2 cycles, one original reality gives rise to 49 sextillion simulations. At that point, the ratio of non-simulated reality to simulated reality becomes 1 to 49 sextillion, meaning the chance that our world is the singular non-simulation is 1 in 49 sextillion. If the reality we inhabit were truly non-simulated, it would be an event of vanishing probability, a veritable miracle. This then is the statistical basis for believing our world is a simulation. Thus far, we have bolstered the simulation hypothesis using the law of accelerating returns. Since we're here, let's also touch on Einstein's principle of the constancy of the speed of light. From that law as well, we can draw reasons that support the simulation hypothesis. Many argue for the hypothesis on the grounds that the universe has an upper speed limit. Black holes are often cited. In regions of extreme mass, supergravity zones, time appears to pass more slowly. Some suggest that scarce computing resources in such areas cause processing to lag, making time itself run slow. Yet that seems improbable. engineers capable of building an advanced simulation would hardly resort to such crude design. Even without that odd explanation, the light speed principle offers a rational way to reinforce the simulation idea. If one designed a system with absolute distance or time as the baseline, jumps in local mass would change the computation required. Subdividing space into ever finer grids to model the universe accurately would drive cost and complexity sky high, and management overhead would explode in proportion. In technical terms, that is a variable length approach, where each datum or variable differs in size. A fixed length scheme, by contrast, makes every datum the same size. Compared with fixed length, variable length grows data volume and management cost exponentially, and soon becomes unmanageable. So why bother slowing light or stretching time in proportion to gravity? There is simply no need. What if we abandon absolute distance and time and instead make speed the absolute standard? Viewed through that lens, the speed of light always advances a fixed number of particles at fixed intervals. In other words, what we call light speed is a clock tied not to distance, but to the tick rate of the universe's smallest units of space. Translate that into computer terms and you get uniform, predictable processing, a structure that is simple to manage. If our world is a simulation, the motion of particles would follow some fixed clock frequency. In massive regions, they would merely move more slowly relative to that clock, an elegant and efficient design. From the standpoint of total processing load, that model is both reasonable and beautiful. It is this computational elegance that makes the universe feel so computer-like. Virtual Earth. We began with the proposition Earth is a sphere as a springboard into the nature of science. But before delving into our roots, let me introduce the idea of a smart Earth. A smart Earth is a planet-scale cognitive environment that humanity may equip itself with in the near future. In other words, the entire Earth would become a thinking platform. In today's VR industry, the term digital twin is everywhere. A digital twin links real-world metadata to virtual space, creating multiple worlds almost indistinguishable from reality for ultra-precise simulation and environmental control. Metadata means environmental and behavioral data. Through IoT and tens of thousands of low-orbit satellites and other sensing, extremely high-definition information will soon be gathered automatically and used proactively. Thus, alongside the real Earth, virtual Earths built from metadata will be created one after another, forming a system in which the planet can be reborn to suit humanity. This is what we call the smart Earth. Coexisting with AI, neural lace. Though the technology raises ethical issues, it is expected to be achievable in about 10 years and mainstream in 20. That may sound unbelievable, but such forecasts are based only on current technology levels. Existing AI has already surpassed 10-year predictions, with breakthroughs turning formerly impossible fields into realities. If neural lace enables coexistence with AI, the boundary between virtual and physical space will vanish, and still more simulated worlds will arise. Free energy. Even if humanity obtained free energy right now, daily life would hardly change. The sun is already free energy, and you could say oil, springing up on its own, is another form of it. What we pay for in acquiring energy is not the energy itself, but the people who supply it. For energy to be truly free, available anytime, anywhere, in any amount, we must wait for non-human labor to emerge. When non-human labor arrives, that will mark the era of genuine free energy, and only then may humanity gain true freedom, whatever freedom means. What freedom is, I cannot say. At the same time, we will surely seek even greater freedom in virtual space. Perhaps we are simply too busy for that right now. Our roots. Even if this world were a virtual one created by something or someone, it might not be so surprising. After all, most of humanity believes in some creator god. Whatever that being's form or power, there must be some creator, a starting point. We cannot conceive of a universe with neither beginning nor end. Modern thinking holds that our roots lie in proteins that arose spontaneously on an Earth about 600 million years old within the young solar system. roughly 400 million years after that, about 3.5 billion years ago, our direct ancestors, prokaryotes, are said to have appeared. Recall the reasoning behind the simulation hypothesis. Once anyone, anywhere starts a simulation, the virtual beings within it will eventually start simulations of their own. Thus, one reality spawns an astronomical number of virtual ones. The hypothesis is drawn from that probabilistic view. Applying the same probabilistic lens to the origin of life yields an intriguing insight. Earth has faced at least 5 extinction-level crises, so our odds of surviving to the present were said to be below 30%. Large meteor impacts were likely responsible, and in future, another unavoidable extinction threat may arise. What would we humans do then? Options might include migrating to Mars or Venus, or finding an Earth-like planet around a nearby star and moving there. Any number of evasive tactics. Humanity would examine and implement nearly every option, unsure which is best, taking every measure to keep our species and earthly life alive. One perennial sci-fi idea is to freeze human germ cells and send them, with life support equipment, to potentially habitable worlds. That method ships vast numbers of humans to many locations with minimal resources, greatly boosting our survival odds as a species. Perhaps not only humans, but long-lived plants or bacteria would be included. In any case, humanity would make no compromises in preserving our line, flinging germ cells, eggs, or seeds across the entire galaxy. Earth itself might perish after our escape, yet life bearing our genes would flourish throughout the Milky Way. Sharp listeners may see where probability enters again. Are we life that arose spontaneously, or descendants of organisms born somewhere else in the galaxy? From a probabilistic standpoint, whether 1 billion or 5 billion years ago, the first intelligent species to face extinction in this galaxy would have broadcast its genes far and wide, and there may have been more than one such species in danger. Those genes, spread across the galaxy, would found new civilizations on the planets where they landed. Thus, for every original life form that arose, tens of thousands or even hundreds of millions more would follow. Which of the two are we? As you can see, the probability that earthly life arose spontaneously approaches 0. Our roots may lie with life first born on some distant star. If so, most life in the Milky Way could share the same genes, be, in effect, the same species as us. Whether we look at the simulation hypothesis or the extrasolar origin hypothesis, we are forced to conclude that the odds of us being the original are vanishingly small. So what then does it mean to be original? Now everyone, back to the very first question. Can you truly say you are here right now?
Not here, but look, arms, legs, I'm moving, aren't I?
Can you say with certainty that that perception is correct?
What?
What exactly is this reality that you and I feel? And can we truly say that we exist at all?